start a section that covers negative exponents. And up to this point, the only exponents we've seen are these positive numbers. 2 to the positive third, 4 to the positive second, and in this case, this actually ends up being 13 to the positive 8. What we're going to be doing in this section is we're going to be covering what happens if this number on top becomes a negative exponent. And what I can tell you does not happen is that these numbers do not change to be negatives, because we need to remember the base is still a positive 2, and the base is still a positive 4. So the base number does not change to a negative at all. Okay, and we'll show you what actually happens in the next set of examples. So let's imagine for a second that we have this problem, 1 over 4 to the negative second power. This is not 1 over negative 16 at all. But what I like to think about is if we have exponents, I like to think of negative exponents as unhappy people that need to move. They want to move, they're unhappy. And positive exponents, I like to think of happy people. They don't need to go anywhere. Okay, that's happy. Okay, negative exponents, unhappy. Positive exponents are happy. So in this case, we have an exponent that needs to move. Now, there's only 2 places that you can go in a fraction. Therefore, this exponent needs to move up to the numerator of this problem. And in the process of moving, it becomes happy. It ends up being 4 squared. Now, since there's nothing in the denominator, we need to make that a 1. But in the process of moving the fraction, we make the exponent happy. The way that I like to think of this is imagine the state of South Dakota with a line cutting through Sioux Falls, just like our interstate does. Above Sioux Falls, we've got SDSU. That's where I went to school. And below Sioux Falls, we have USD. That's where my sister went to school. I don't like Vermilion at all. I don't like being in Vermilion. I don't like talking to people from Vermilion. I am an SDSU person. I'm a winner, okay? If I'm down here in Vermilion, I'm really unhappy. I don't like it there. I want to go back to Brookings. But at the same token, last year when I showed this video, Jake Cheeseman talked about how he doesn't like being in Brookings at all, and he wants to go back down to Vermilion. So if we look at this example right here, what we have is we have Jake Cheeseman, we have Mr. Schmidt in Vermilion. Okay, I do not like it down in Vermilion. I'm very unhappy. So I'm going to go back up to Brookings, and now I'm happy because I'm back where I want to be. So let's say if we have the example, let's go 3 to the negative third power. Well, that's Jake Cheeseman now, and he's in Brookings. He doesn't like it there at all. So he wants to go down below the fraction bar back to Vermilion. And when he goes back down to Vermilion, he is now happy to be there, and he's now a positive exponent. So that's how I like to think of it. I use it as an example of SDSU and USD. If you're on the wrong part of the fraction, you need to move. And in the process of moving, you become a positive exponent. Now, here's the other way to think of it. If you see negative exponents anywhere in a problem, you need to think one word: fractions. Okay, and I know that's everybody's favorite topic. One word: fractions. So, if you see a negative exponent, your problem will have a fraction in it somewhere. So let's show another way to think about these problems, okay? If we have 2 cubed, that's equal to 8, because that's 2 times 2 times 2. 2 squared, well, that's equal to 4. 2 to the first, well, that's equal to 2. And if we look at each step of this problem, I am constantly dividing by 2. As the exponent decreases, I divide by 2. Well, 2 to the 0, we remember anything raised to the 0th power is 1, other than 0 raised to the 0th. So I'm still dividing by 2. Therefore, if I have a negative exponent, I have to do 1 divided by 2. So I end up creating a fraction. And then if I divide 1/2 in half, I end up getting 1/4, which in this case will be 1 over 2 squared. By moving the exponent to the denominator, I made it positive. Let's show another example. If I have 5 to the positive second power, that's positive 25. 5 to the first, well, that's 5. Once again, I'm dividing by 5 on each step. 5 to the 0, well, that's 1. Therefore, my next step is 1 over 5 to the first, which has to be 1/5. My next step after this will be 1 over 5 squared, which is 1/25. And now this will be 1 over 5 cubed, which is 1 over 125. When we have negative exponents, we create fractions. So let's look at a few examples of what this actually looks like in actuality. The first problem is we have 6 to the negative third power. Well, we have a person on the top of the fraction bar, so they're in Brookings and they're unhappy. So I want to send them down to Vermilion. And when I send them down to Vermilion, now they're happy. Once I have positive exponents through the entire problem, then I solve it just like any other problem. So 6 cubed, that'll be 6 times 6 times 6, which is 1 over 216, or 1/216th. So that's how you solve the problem. Over here, now we have two numbers. Only one of those numbers is negative. So this is in Brookings, and it loves it there, like a true winner. But 5 to the negative fourth, they want to go down to Vermilion, so now they're happy down in Vermilion. So we have 5 squared over 5 to the fourth. Everything is now positive, so I could solve this. I could do 5 times 5 on the top, and on the bottom I could do 5 times 5 times 5 times 5, and I could simplify. But that's a really difficult way to solve this problem. So here's what I do. I write out 5 times 5 on the top, and on the bottom I write 5 times 5 times 5 times 5. Okay? Well, I know that 5 divided by 5, right here, is equal to 1. So that's gone, because that's just equal to 1. Well, I can do that process again. This is also equal to 1, so that can be ignored. So on the top of the fraction, I only have 1 left. And on the bottom, I have just 5 times 5, or 5 squared. Well, then I just simplify that into 1/25. Not easy, but also not impossible. Let's move to a couple more examples. Up here, we have 3 numbers, x to the fourth, x to the negative third, and x squared. X to the negative third is the only exponent that needs to move. Therefore, x to the fourth and x squared stay up on the top of our fraction bar. And x to the negative third is going to move down to the bottom and become a positive exponent because it's now moved, so it's happy again. In order to simplify this fraction, I'm going to do just like I did with regular numbers. I'm going to do x times x times x times x. That's x to the fourth. Then I do x squared. And on the bottom, I do x times x times x, and that's x cubed. So on the top, I actually had x to the sixth, and on the bottom, I have x cubed. Once again, I'm going to simplify. These two x's divide to be 1. These two x's divide to be 1. And these two x's divide to be 1. So that means on the bottom, I have 1 left, just the number 1. And on the top, I have simply x cubed. So I could do x cubed or x cubed divided by 1. I prefer the answer on the left. Let's do another. If I have 6 squared on the top, that's going to stay. 4 to the negative third needs to move down to the denominator, and it will become a positive exponent when it goes there. But we have a problem. These have different bases, so we can't simplify this like we would do a normal problem. So we have to simply do 36 on the top, and this is 4 times 4 times 4, which is 64. And now I just simply simplify like I normally do, and I'm going to divide both of these by 4. This gives me 9/16. And that is my answer. If you left it like this, it would be partially correct. If you left it like this, it would be closer to partially correct, but the boxed answer is the best possible answer. Let's do one final slide. This is as tough as the problems can get, okay? So this is like a level 4 problem. We have 6x squared on top, 2x to the negative second on bottom. The first thing I want to do is anything without an exponent, I want to separate. Well, 6 and 2 are just regular numbers, so I'm going to go just 6 halves. That's going to be to the left of the problem. And on the right of the problem, I'm going to do x squared over x to the negative second power. Now, I want to change anything with a negative exponent to a positive exponent. So I'm going to move this to the top, and I get 6 halves times x squared times x squared, because it's now a positive exponent. I'm going to erase that and try again here. X squared. Okay, now we need to simplify. Well, this is x times x, and this is x times x. So that gives us 4 x's right there. And then 6 halves is 3. So our final answer is simply 3x to the positive 4th. And now let's do the problem on the right. Once again, we need to break this up. We have 12 fourths times, we're going to do y to the negative third and y to the negative second. But this time we have a negative exponent here and a negative exponent here. So this one is going to move up, and this one is going to move down. So they're actually going to switch places. So we get 12 fourths times, we get y to the positive second on top, y to the positive third on bottom, which gives us, this changes into a regular 3. And now this is where it gets a little tricky. So y to the second is y times y. Y to the third is y times y times y. Okay? So I can get rid of 2 y's on the top and 2 y's on the bottom because that all divides to be 1. So that means I'm left with 1 over y, which gives me 3 over just y. This could also be written as 3 times y to the negative first. If the problem is okay with the negative exponent, I am always going to prefer the fraction answer. So that was a ton of information in a very small amount of time. I do not expect you to have this mastered, but I'm hoping this gives us a good starting point. So come and talk to me if you need more help. And as always, if you ever need any help, please let me know as soon as humanly possible.